This is John Black, super chemist. I want to go over how to make simple acids. I want to start with the hydrogen halides. So how do you do that? Well, you just drip a stronger acid on the salt of the acid you want. And I'm not going to go over fluorine, hydrofluoric acid, because it's not something a home chemist really gets into with fluorine. So I'm not going over that, but say hydrochloric acid. A stronger acid than these two, hydrochloric and hydrobromic, is sulfuric. That's the go-to acid, sulfuric acid. You can drip it onto the salt of this, meaning you need a chloride. I put sodium chloride, it could be potassium chloride, whatever. As long as it's a chloride, and obviously you're going to use table salt because that's cheap, that's, accessible. Drip the acid, here's your acid in your set funnel. You drip it into here, and it will make the it'll make the gas, the hydrogen chloride gas. If you want that, that's great. But if you want the acid, you'd have to lead it with a tube into this thing of water here that's in the ice bath, because that's more soluble. Gases are more soluble in cold liquids. Solids are more soluble in hot liquids, usually. So this would be your sulfuric acid, and this would be your salt. If you wanted hydrobromic acid, you'd use sodium bromide, right? Now, you could use water here too if you wanted to distill out the azeotrope. I do not suggest it for hydrochloric acid. It really sucks. You lose all your HCl to gas. It's terrible. It's a terrible method. I tried it once. I will never do it again. It's stupid. I've never done hydrobromic, so I don't know if the hydrogen bromide gas is going to come out like it does with the HCl. I don't think it does, though. So you could put water in here, and then it'll absorb all the gas, right? So you don't have to lead it into, you close this up, drip it in there, and then you can set up for distillation and distill it out as an azeotrope. Now, hydriodic acid, okay, the iodine, that reacts different now with sulfuric acid. If you drip sulfuric acid on any kind of like sodium iodide, it's such a strong oxidizer. It'll oxidize that it'll oxidize the iodide up to iodine, right? Because when it's iodide, it's negative, a negative ion. When it's iodine, it's neutral. So it obviously was oxidized. Oxidation is good. It's on the right side of the list. That's the best thing in the world. They're great people, so they're oxidized, and he was negative, and sulfuric acid oxidized it up to neutral. You know what I mean? Took his bills away, and now he doesn't owe anything. He doesn't have anything, but he doesn't owe anything like he did before, right? So he's oxidized. So what you would do is you would drip phosphoric acid onto like sodium iodide, and then you can distill out your hydriodic acid. And that way, the phosphoric acid won't oxidize the sodium iodide to iodine. It will just make the acid. Now I want you to look at this. Here's an example of the sodium chloride and the sulfuric acid to make hydrochloric acid. Now if you do it at room temperature, this is what's going to happen. You're going to make the bisulfite. You can see you're just switching around. The protons come over to the chloride, and the sodium goes to the sulfate. That's it. But if it's at room temperature, once you make your bisulfate, bisulfate sucks as an acid, and acids are oxidizers, so that means it sucks as an oxidizer. But that's neither here nor there. It won't react any further at room temperature. You have to take it up to, I think 200, maybe Fahrenheit, I can't remember. But you have to take it up to 200 degrees, maybe it's Celsius, I don't know. For the bisulfite, or sulfate, to react and make more hydrogen chloride. Okay, and then if you have it at 200 degrees, you would be doing this. So I'm saying temperature has a lot to do with it, especially when you use sulfuric acid, because it's diprotic. It has two protons, and once you remove one proton, this is a crappier acid. You just took strong acid down to a crappy acid or a medium acid, you know what I mean? Uh, so keep that in mind too. How do you make other acids that aren't the halides, right? Here's some examples here. Okay, here's some examples here. You got, let's say you want phosphoric acid. Well, like I said, get sulfuric acid, drip it on the salt of the acid you want, which would be a phosphate, tricalcium phosphate. Drip it onto there, and then this is what you get. Calcium sulfate is not soluble. You'd filter it out, and what you're left with is a dilute acid that you could, well, it's not dilute, but you can concentrate it better by evaporating the water off. You know, put it in a distillation apparatus, distill a lot of the water off, and it'll keep, just like with sulfuric acid, it'll keep concentrating the phosphoric acid if you distill off the water. And then you'll have pretty pure phosphoric acid. You can even distill it too, you know what I mean, to make it definitely pure. I don't know what the AZ truck goes up to, I don't know. Let's say you wanted nitric acid. Same thing, you get this nitrate salt, you drip this sulfuric acid on it, right? Once you do that, you can distill this out 83 degrees or 86 degrees or whatever. Same with even carboxylic acids. Like, how do you make acetic acid or ethanoic acid? You take sodium acetate and you drip some sulfuric acid on it. These two I did videos on, so you can watch them if you want. Did a video on hydrochloric acid, but I didn't actually make it, I just was talking about it. And here's just an interesting one here. You can take phosphorus, drip nitric acid on it, and you'll get your phosphoric acid, but you also get 5. You can see all the nitrogen goes to form NO2. Just nasty stuff. Plus it'd be trying to go into the water, so you'd have nitric acid and phosphoric acid both. But it's just an interesting equation. If you have an oxyacid, you can always just throw the acid anhydride in some water and you'll make your acid. What is an acid anhydride? The best way to explain that is with sulfuric acid. And keep in mind, if you're going to do this, let me know, because there's more to it, especially with sulfuric acid and phosphoric acid. Really all these. This is really exothermic things, and you can have explosions, especially when it comes to the anhydride of sulfuric acid. You actually already have concentrated sulfuric acid, and you would bubble in the acid anhydride into the already concentrated sulfuric acid, you know what I mean? And then and then that way you make oleum, and then you would dilute the oleum back down to concentrated sulfuric acid. But anyways, look at this. If I take a water molecule off of this, H2, then I take off one O over there, that'd be SO3. That's your anhydride. What if, okay, now what if I had sulfurous acid? That's SO3. See, H2SO3. Take the H2 off, take one of the O's off, and I'd have SO2. That's my acid anhydride of that acid. Now you can use hydrogen peroxide to help you out too. Like if I used this anhydride, it's for this acid, but I used hydrogen peroxide, I can make that up to sulfuric acid, because this would oxidize it. You'd make your sulfurous acid, but then this would add an oxygen to that, and you'd make sulfuric acid. Now here's phosphoric acid. It's kind of different. You can't just take a water molecule off of there. Doesn't come out right or whatever. But anyways, you would add this to the water, and again, this is very exothermic. Do not do this. This is how the people that are, you know, in business have big factories and machines, and they can contain heat and have a certain catalyst and, you know, all this other stuff. And again, you'd have to have pretty much pure phosphoric acid in the first place before you added this. You know what I mean? And then you can add a little bit of water to make it pure or whatever. You know what I'm saying? nitric acid. There's two methods here. You know, you can do the hydrogen peroxide or you can not. Either way, you're going to make that. But here you got NO up there, so you got a better chance with the hydrogen peroxide. It's better. But what about going down one, like up here? We went down to nitrous acid instead of nitric. You got to do it in colder because it's not stable. But this is your acid anhydride, N2O3, dinitrogen trioxide. You would add that to water, and you would get your product. You can see there's no byproducts. But, again, there's always stuff going on that you don't realize. Like, see how NO2 to water is nitric acid? Is it, though? Because really it's this. NO2 and water makes this, but this, unless it's cold, and even in the warm, it's gonna be oxidized back up to this. You know what I mean? Maybe that's what this does. I don't know. But you can see there's always, you know, just like adding this to this. Adding this to this. There's always something in between sometimes. Like maybe it goes to this first, and then this oxidizes it to this. You know what I mean? And there's always things that, you know, can explode or whatever, or that are exothermic. So always ask if you're ever going to do anything that you don't know about, you know what I mean? Because these are just 15-minute videos trying to give you some tips or whatever. This isn't telling you everything. I do have a video on sulfuric acid, not how to make it, but how to get it. I do talk about the dangers in there, so maybe you should watch that if you're going to try to do any sulfuric acid. And hypochlorous or hypobromic or bromous acid. And the way you do that is you get chlorine and you put it into water. And what happens is this propionates, or whatever that word is, where it goes up and down. In other words, one gets oxidized and one gets reduced. One gets the hydrogen and you're left with an OH, so the other one gets the OH. Anyways, same with bromic acid. You can see, if you know one reaction, you know 10 reactions. Like I know this reaction, so therefore I know this reaction. It's going to be the same exact thing. I just replace all the chlorides with bromine. Because they're all in group 7. They all have 7 electrons. So all I need to do is memorize this. I don't need to memorize this. Now what's the salt of this acid? This is going to have an an OCl part on it. How do you do that? Instead of putting the chlorine into water, you put it into sodium hydroxide solution. And you can see all I did, this is just water. Pretend this Na is an H. Okay? Now what's the difference between this formula and this formula? 0. Just the blue, I changed the H to an Na. So if I know this formula, then I know this formula. Because I just look at this and I say, oh, this is chlorine and water. They replace the H with an Na. So I just replace all the H's with NAs. So not only do I know all of these formulas with the Cl, the Br2, you know, the iodine, I also know when you change the water. You just change one thing. If you change the halogen, you change the halogen. If you change the proton to an, you know, a potassium or a sodium, then you do the same thing over here, all through the equation. It's the same equation, though. That's chlorine. When I made chlorine in my one video, I used calcium hydroxide. I used calcium hypochlorite, and it said 68%. This is why, okay? When you do this, you make the salt of this acid, you're going to come up with a mole ratio of 1 to 1. But look, you got an extra oxygen in there. So weight-wise, this is going to be more. This is going to be 68%, and this is going to be the remaining. So anyways, I'm going to wrap it up because I know I'm running out of time here. You guys all have a great day, and remember, science, always remember science is great.